Hey, this is part 4 of going over chapter 4. Last problem, number 7. Here's what we got. We got the ladder against the house problem. The ladder is 18 feet long. It says when the base is 6 feet from the house, the base is moving at a rate of 7 feet per second. Okay, part A. Look at part A. What value in the above sentence is a value for dx dt? First of all, dx dt, that's a rate. What's the only number up here in the sentences that is a rate? Boom, right there, you got it. Hey, there we go. dx dt is 7 feet per second. Okay, nice. Okay. Part B. When the x value is 6, the ladder is always 18. How big is the y? Well, here's what I see on this one. Okay. The ladder is always 18. That's not changing. When the x is 6, how big is the y? Oh, yeah, just Pythagorean theorem. Okay. Here we go. Let's see what we got. Y squared plus 6 squared equals 18 squared. Okay. Let's see what we got. Yeah, there we go. Okay, nice. Minus 6 squared here, minus 6 squared here. Y squared equals 288. Take the root, take the root. Here's my y value. My y value is 1697. Okay, so y equals 1697 what? Yeah, feet. Okay, now, our next one. What is the equation that relates an x, a y, and the 18-foot long ladder? You're not plugging any numbers in this. I want an equation that relates x, y, and 18, and there it is right there. There it is. Okay, let's go right here. Hey, it's going to be x squared plus y squared equals 18 squared. Now, part D, the derivative of part C. Here we go. Now, is the x changing? Sure it is. It's getting bigger. As the bottom of the ladder slides out, the x is increasing. There's going to be a dx dt. Is the y changing? Absolutely. The top of the ladder is sliding right down along the side of the house. The y's getting smaller. The y's changing. There's going to be a dy dt. So here we go. First of all, derive the outside, 2x. Derive the inside, yeah, dx dt. Plus, derive the outside, 2y. Derive the inside, dy dt. Equals, what's the derivative of 18 squared? Yeah, big 0. Okay, now let's see if we could start plugging everything in. First of all, do I know an x value? Yeah, I do. It says when the x value is 6. Okay, good. I got x equals 6. That's right here. Do I know a dx dt? Yeah, it's 7. Right there. Do I know a y value? Yeah, it's 16.97. Great, right there. The only thing I'm looking for is dy dt. Let's start plugging it in. 2 times the x is 6. Then dx dt is 7. Okay, plus 2 times the y value was 1697 times dy dt equals 0. Okay, here we go. What do we got here? We got 84 plus, we got 3394 dy dt equals 0. What are you going to do now? Yeah, subtract. Okay, so here's what I see. 3394 dy dt equals negative 84. Divide by 3394 here. Divide by 3394 here. I'm going to write it right here. dy dt. It will be negative, and it turns out it's negative 2.47. Negative 2.47. How about the units? Y was in feet. Time was in seconds. Why is it negative? Because the Y value, this right here, this Y value right here is getting smaller. If a value is getting smaller, then its rate of change is negative. Boom. That wraps up chapter 4 review.